the inverse sine, cosine, and tangent functions. Chapter 7, Section 1. All right, so let's take a look at the inverse sine function. Now, if you think about all of the trigonometric functions, they're not one-to-one. And to have an inverse function, the original function needs to be one-to-one. But if you have a sine wave, obviously that's going up and down, right? So it fails the horizontal line test. It's not a one-to-one function. So what we do to create an inverse function for a trigonometric function is we find an interval over which that trig function is one-to-one. And you can see here that for the sine function, we chose the interval from negative pi over 2 to pi over 2. That's this red curve that you see there, and you can see the dotted lines to continue it into that sine wave. But that gives us an interval over which the sine function is one-to-one. Since it's one-to-one at that point, we can find its inverse function by reflecting it over the line y equal to x. And that's that diagonal line that you see there. And we get this black curve is our inverse sine function. You should notice with this too, that that is only a portion of the curve, right? We're from negative pi over 2 to positive pi over 2. That's pi. That's only half of our sine curve. So we're not really looking at the full sine function. But where that fits in and where we'll see it fit in is in reference angles that we can use the information from that pi, that half of the period of the sine function, to work with the whole 2 pi or full period of the sine function when we're dealing with inverse sines. So we've got this. So now we see that the red curve is our original sine function. The black curve is a segment of the inverse sine function, or is the inverse sine function for that same segment that we've got there. So y equals sine inverse of x. So notice that we've got that -1 over the sine. That's saying take the sine, the inverse function of sine. It's not saying to take the reciprocal of sine, so just be careful. Sine -1 of x is not the same as 1 over sine of x. You're not taking the reciprocal of it. It's saying the inverse function. It's the same as saying f of x and f to the -1 of x. So it represents the inverse function. Just be careful of that. That's a common mistake that people use. Now, y equal to the inverse sine of x is the same as x equal to the sine of y. So basically, we're reversing the process. If you take the sine of y, you're taking the sine of some angle, and it's then giving you the trigonometric ratio x. If you're taking the inverse sine of x, you're taking the inverse sine of that trigonometric ratio and then finding y, the angle. So in these cases, y, and where x is between -1 and 1, and for the inverse function, and y is between negative pi over 2 and pi over 2, which should be obvious. Remember, when you're dealing with an inverse function, all you're doing is flipping x and y. So in our original red curve here, we see that x was from negative pi over 2 to pi over 2. So now for the inverse function, y is from negative pi over 2 to pi over 2. In our red original function, y was from -1 to 1. So now in our inverse function, x is from -1 to 1. And since these are inverse functions, we can take f of the inverse function of f of x and say that this inverse sine of the sine of x is equal to x. So if we take the sine of an angle and get a trigonometric ratio, and then we take the inverse sine of that trigonometric ratio, that takes us back to that original angle x. And that's where x is between negative pi over 2 and pi over 2. And then in the same line of thought, if we take the sine of the inverse sine of x, so if we take the inverse sine of a trigonometric ratio x and then take the sine of that result, we get x back again. We get the trigonometric ratio back again. And that's where x is between -1 and +1. So I know this is really, I don't want to say confusing, but there's a lot going on. And it's kind of just getting used to the feel of it. Remember that an inverse function just undoes the function. And that's really what it's saying here. If you take the sine of some angle, you're going to get a trigonometric ratio. If you take the inverse sine of a trigonometric ratio, you're going to get an angle. And the same thing occurs for the inverse cosine function. You can see here again that the red line or red curve represents our cosine function, and we're taking it on the interval from 0 to pi. And then you can see that by doing that, we can then reflect that over the line y equal to x, and we get this black curve, which is our inverse cosine function, which now goes from -1 to 1, which was the range of our original cosine function. And same thing, y is equal to the inverse cosine of x means that x is equal to the cosine of y. If you take the inverse cosine of a trigonometric ratio, you get the angle. If you take the cosine of an angle, you get the trigonometric ratio. And again, we can see that for the inverse function, that x is between -1 and 1, and that y is between 0 and pi. If you take the function of the inverse function, you will get x. So if you take the inverse cosine of the cosine of x, you get x, where x is between 0 and pi. And if you take the function of the inverse function of x, where cosine, you take the cosine of the inverse cosine of x, you'll get x. So if you take the inverse cosine of a trigonometric ratio and then to get an angle, and then you take the cosine of that angle, you get back to that trigonometric ratio x. If you take the cosine of an angle and then you take to get a trigonometric function, and then you take the inverse cosine of that trigonometric function, you end up back at that angle x. And I know it gets a little confusing using x all over the place like this. But remember, x is just a variable. It can represent anything. But if you start with an angle, take the trigonometric function of that angle, you're going to get a trigonometric ratio. If you take the inverse trigonometric function of that trigonometric ratio, you end up back at the original angle, and vice versa. So the inverse tangent function, we can see here that that dotted line or dotted curve is our tangent function. And we can see that when we reflect that over the line y equal to x, we get that green curve there, giving us our inverse tangent function. You can see that for our dotted curve, that x is between -pi/2 and pi/2. Remember that for the tangent function, -pi/2, pi/2, 3pi/2, those are all asymptotes. So we can see that the x values of our tangent function running from -pi/2 to +pi/2, and the y values being from -infinity to +infinity. So then when we flip them, we end up with the x values of our inverse tangent function being from -infinity to +infinity, and our y values being from -pi/2 to pi/2. So we see that y equal to the inverse tangent of x is the same as saying x is equal to the tangent of y. For the inverse tangent, X can be any real number, and Y is anywhere from negative pi over 2 to pi over 2. And just as before, if you take the function and the inverse of the function, so if we take the inverse tangent of the tangent of X, we're going to get that original X value, that original angle back, and it's going to be anywhere between negative pi over 2 and pi over 2. And if we take the tangent of the inverse tangent of X, we're going to get X, which is the original trigonometric ratio, and that's going to be anywhere from negative infinity to positive infinity. So that was very wordy and maybe visually disturbing. I apologize for that. Maybe I should have put a parental advisory warning on here before we got started. But now let's look into what it really does for us and why we use this. So what if we want to calculate inverse trig functions? Now, on any scientific calculator, you have the ability to calculate inverse trig functions, at least sine, cosine, and tangent. And in this section, that's what we're talking about is sine, cosine, and tangent. So any calculator you go on. So if I look at the inverse sine of 1/2, what I'm really looking at is sine of some angle is equal to 1/2. That's really what it's saying. Sine of what angle is equal to 1/2. And if we think about those triangles that I drew previously, remember I had my 1, 2 square root of 3 triangle that gave me 30 degrees and 60 degrees. And then I had my 1, 1 square root of 2 triangle that gave me 45 degrees. If I think about that and go sine is opposite over hypotenuse, then if I have the inverse sine of 1/2, that's opposite 1 over hypotenuse 2, we should be able to realize that that happens when we have a 30-degree angle, because this is one of our standard angles. And you can go back to our unit circle drawing. And for the standard angles, you can look at that and you say, okay, well, where is sine equal to 1/2? Oh, it's at pi over 6 or 30 degrees. So don't be afraid to use that unit circle to recognize these and find them. Otherwise, just quickly draw those two triangles, which I showed you, and you can pull these out of it. So that's using a standard angle. Another one looking for a standard angle, the inverse cosine of the square root of 2 over 2. So we've got cosine with a trigonometric ratio of the square root of 2 over 2, which could be written as 1 over the square root of 2. So when we look at that, 1 over the square root of 2, cosine is adjacent over the hypotenuse. So the adjacent would be 1, the hypotenuse would be the square root of 2. Oh, that's my 45-degree angled triangle, right? So the inverse cosine of the square root of 2 over 2 is pi over 4, or 45 degrees. And again, you can use the unit circle for these to recognize and pull out. Now I say that with myself saying you can use the unit circle. Remember that certain instructors, especially in calculus and such, will just assume that you can recognize those standard angles and what the ratios are. So if you can get yourself to the point that you can memorize those or calculate them really quickly, meaning create the triangles that have them available for you, then go ahead. In this course, I don't require you to take it to that point. And then the inverse tangent of the square root of 3, well, that's the same as the square root of 3 over 1. And tangent is opposite over adjacent. And if we think of 1, 2, square root of 3, then that must be the opposite, like I said, opposite over adjacent. So I got 1, 2, square root of 3, Opposite is the square root of 3. Adjacent is the 1. So that puts us at the pi over 3 or 60-degree angle. And again, you can look that up on the unit circle. Now that's doing it from our standard angles. So the 30, the 45, the 60 degree. We can also just use our calculator to do this. So nothing says you have to do these in your head. In fact, many times you can't. You're not going to take the inverse sine of negative 0.72 and do that in your head. Now, what I will point about this is obviously we're going to use a calculator for this, but you need to remember what unit you are in your calculator. Is your calculator set to radians or degrees? And depending on the question you're working on, you may need the answer back in a specific one of those radians or degrees. But I did this using both. So if I take the inverse sine of negative 0.72 and my calculator set in radians, I get approximately negative 0.80 radians. If my calculator is set in degrees, I get negative 46.05 degrees. And again, that's approximated. Now I will point out with this two things. One, notice that my angle is a negative angle. So we may prefer to write that as a positive angle, which would mean that we, for the degrees, just take 360 and subtract 46.5, which gives us what, 313.95 degrees. For our radians, we would take 2 pi and subtract that 0.80. So we can put it as positive or we can put it as negative. Our calculator gives it to us as a negative angle. The other thing to realize with this is that your calculator is going to give you the reference angle, which is the angle in relation to the x-axis. But we know that sine is negative in both the third quadrant and the fourth quadrant. So not only would this work as, and I'm going to put it in degrees because it's easier to work that way, not only could I rewrite this sine of the inverse sine of negative 0.72 as negative 46.05 degrees or as 313.95 degrees, I could also find it for the third quadrant, which would make it 180 plus 46.05 degrees or 226.05 degrees. So realize that there are two quadrants. All students take calculus, so sine is negative in the third quadrant and the fourth quadrant. So that 46.05 degrees, that's telling you that's a reference angle. In relation to the x-axis, it's that far away. The negative sign tells us it's in the third quadrant or the fourth quadrant. So we're going to subtract it from 360 or we're going to add it to 180. Let's look at another example. The inverse cosine of 0.47. If I plug that into my calculator with radians, I get 1.08 radians, or with degrees, I get 61.97 degrees. Cosine, all students take calculus. Cosine is positive in the first quadrant and in the fourth quadrant. So 61.97 degrees, that's in the first quadrant. In the fourth quadrant, I could subtract that from 360, giving me 298.03 degrees. So it can be in either of those two quadrants. So do realize that even though your calculator gives you always a reference angle, it's going to give you an angle that's less than 90 degrees or less than pi over 2 if you're dealing in radians. that we can then relate that to the other quadrants where that function has the same sign, SIGN. Well, what about tangent? So tangent, if we take the inverse tangent of 4.56, then our calculator tells us that's 1.35 radians or 77.63 degrees. All students take calculus. Tangent is positive in the first quadrant and the third quadrant. So 77.63 degrees is correct, or 180 plus 77.63, which gives me 257.63 degrees, would also work in the third quadrant. So just keep that in mind, that when you're taking the inverse tangent, inverse cosine, inverse sine, that there's actually two quadrants that the angle could be in and still have that same value. So make sure you check that. In fact, looking over again at what we did on this left-hand side here, sine, the inverse sine of 1/2, sine is positive in the first and second quadrants. So that could be 30 degrees, or it could be 180 minus 30, so 150 degrees. So 30 or 150 degrees. Cosine, and the inverse cosine of square root of 2 over 2, cosine is positive in the first and fourth quadrants. So that can either be 45 degrees or 315 degrees. And tangent's positive in the first and third quadrants. So therefore, that could be 60 degrees or 240 degrees. And that's the start of inverse trigonometric functions.